Hey guys, Joshua Peterson, Peterson Electric. Fourth part of this video for the Power Out Motel here in Loveland. Thought about one other thing I wanted to share with you real quick. So we went ahead and energized this. We checked all the connections in here as well. We energized this side, we turned it on, and now this whole panel's lit, so these lights are finally on. When we're checking for pressure or voltage, because voltage is pressure, we're trying to see is it consistent. So we got 122.1, 0.3, and 122, 123. So a difference of 1 volt between the two phases is really nothing. I've seen as much as 5-6 volts, and it's not really that much of a concern to me. This system is technically called a 122.08, but this will be actually 122.08 single phase, and we're reading about 213, 214. So when we're running about 6 volts stronger, we're allowed typically a plus or minus 10% on most voltage systems by according to the utility standards of some of these Loveland Power and Excel Power in Colorado. So basically the other thing we want to look at here is ampacity as well. Right now we're running about 13, 25 amps. Something's fluctuating. There might be a freezer, refrigerator kicking on. And then right now we're running about 9 to 13 amps. So the difference of that neutral might be anywhere from 6 to 15 amps up to 30 amps as well, because something else just kicked on. So yeah, we're running about 13 to 23 amps on the neutral. So that single part of that neutral is going to take up the imbalance of the two as they fluctuate. The other thing you want to make sure is that we're checking to see that our voltage is strong. So we'll just find a common ground here. And we can check some of our breakers all the way down. And they're going to be the same, 123 to 122 as we go through. So once we've established that, guys, you can do also a simple test as well. Don't worry about the green and the white. Those are just my extensions. But, you know, typically you can check, make sure your lugs have got power. You don't want to cross between the two phases because this light bulb is only rated for 120 volts. And then at that point, I could just establish a ground if I wanted to, just to verify the breaker is producing current coming through. Because the light bulb is actually going to produce about 60 watts there, and therefore it's about a half amp. So if I want the GFI to break, I can come in here to the hot and trip the GFCI because I'm using it on a separate neutral. So the light bulb's coming through to this neutral, which is the main neutral, or that's the ground. But over here, if I did it to the neutral as well, it wouldn't matter. I'm still just not a part of that neutral on the GFI. You can do that for an arc fault as well, and that's how I test them. A lot of guys will just hit the test button. Well, that's great, but you're not really testing, in my opinion, the load side. You're just testing on the breaker. But I'm truly testing the load side of that if I grab another neutral and I just trip it on the hot. But if I wanted to check to make sure that the breaker's working, I'll just go neutral to hot right there as well. No different than a hot tub. And then you can check your phases as well coming down. So anyways, guys, just make sure you're checking your pressure for your voltage, because voltage is pressure, so no different than a water spigot carrying water out to a faucet. You need that pressure there, so when you open it, it releases. So then that would be no different than a switch contacting. And then on the back side of that is going to be what's used up as your wattage. That is going to be like a light bulb or a motor, if it's going to be kilowatt, or if it's just going to be RPM or some kind of motor that's going to have a RPM as well. But after that's done, that's going to continue into what we call volt amperes, and on the back side of that create amperage going back to ground, and that is what your neutral is carrying back. So we're just trying to check to make sure that these breakers are producing the correct voltage coming through from the breaker to the wire, to the bus bar, to the lug, and then wherever it's going out to its load side of the device. Anyways, guys, thanks for joining us. Have a good day.